compiler follows a very strict set of rules where it treats all components the same and all elements the same. So this is basically just all runtime, right? And what's kind of cool about this is we can go back to that original example that I was showing. I didn't give the visual too much, but I was showing that to-do app at the beginning where there was like, all that complexity with the React and the memo, and then they had the crazy compiler and did all that. And I actually built the same app in Solid. And the funny thing is, this has all the added features, but it actually looks exactly like the first version that we started with, where we created our reactive data, we created our handler to update the to-do, and then we listed over it. There's no memo, create memo, no auto cache and compiler, none of all of that. And what you'll see when we update it, is we can, update one of these, and yeah, this increments by one. But if we change the filter and nothing changes, well, the filter is called, but it doesn't create or update any to-dos. If we add a to-do, yeah, I mean, it's going to add a to-do. Let me add one, like, let's add 4. It creates one to-do, it doesn't recreate anything. If I change the theme color, which is a fun one because it actually comes in from a prop from above, so someone's passing a theme through the to-dos, through another component. None of the components in the middle need the update. So I can, change this, have it updating reactively, and none of these function calls are calling. It was actually really hard to make this demo because I had to find creative ways to show what's updating, like putting console logs inside the JSX binding, because nothing runs. Like, this is a very kind of powerful showcase here of what signals do, because you can basically start where your mental model began with and have the most optimal implementation without a fancy compiler or without basically any kind of automated memo, or not automated, mechanical forced automation, mechanical forced memoization, like without you actually having to optimize the code yourself. So I call this the reactive advantage. Components only run once, templates compile to real DOM nodes, and state is independent of components, right? The component boundaries are for your sake, not how you want to organize your code, basically, not for performance. The performance is good regardless. And the reason this is important is it isn't about raw performance and benchmarks. It's that components just aren't a consideration when you're trying to optimize your code or how it runs. Component-based runtimes tend to either be lightweight, but lead to a ton of re-executions, like React, or they make component boundaries of reactivity and pay the overhead based on how you break them apart. Both these push you either making more or less components for mechanical reasons, and push you to think about where your state is to satisfy the framework. For example, too many components can lead to needing to pass things through too many other components, known as prop drilling, and too few cause excess over execution. So like the idea here is UI, tree, and state should be interwoven, but they aren't the same thing. So to kind of sum it up, like I already showed this earlier, is like the fact that you can just move state around is incredibly powerful thing. And as for our compiler, if you aren't careful, you no longer have the language to represent certain ideas. If your whole world, say, is a component, how do you represent what lies outside of? I mean, obviously there's ways of doing this. This is illustrative, but my point is that let count can't be just hoisted up. Like this is compilation is an important tool at our disposal, but it's not the full story. So no surprise to anyone now, but this is part of a larger trend. I may have used Solid to illustrate this, but reactivity has been serving as a common language between UI frameworks, right?